What I want to talk about today is how one of our small clusters has now been federated around the country. So, I use the word federated loosely there because there's lots of complexity with that. So we'll start with who I am. So I'm a mechanical engineer by training who got tricked at multiple points along my career to move into HPC. So a lot of things that I did required HPC, and eventually I got better at it until someone offered me a job. Hopefully they don't realise that I'm a mechanical engineer. So the institution I work for at the moment is Monash University, and they lead quite a few big characterisation projects. So things like synchrotrons, cryo-electron microscopes, those type of things. So those are the things that I look after. So my boss loves this slide. The way that we describe what we do is that we're actually partnering with researchers to make their entire instrument. So we do everything. So typically the researcher comes along with whatever instrument they think is a good idea. And then what I do is add on everything else that they need all the way up to the visualization and publishing end. So where I work, we're really close to the Australian Synchrotron. CSIRO, one of the biggest national labs, is across the road, and we also help them as well. Now, to explain some of the complexity around the federation I need to create, is there a pointer? No. All right, we'll deal without the pointer. So as you can see from this incredibly busy slide that my boss loves to make very busy slides, if you haven't noticed yet, is a gazillion people are involved in this. So the money has been snavelled from every different funder known to man. Universities are very keen if they buy multi-million-dollar pieces of equipment, they want someone to come and help it so that their researchers can actually use it. So the point of this project, the CVL, is to link all of them around the country. There's a shameless plug for my website. So there's two ways to look at the way that we run the project. There is my view as an administrator, and then there's a researcher's view. Typically, I try to focus very much on the researcher view because if I'm doing my job well, they're doing their job well. And so when we have a partnership, if both of us are doing the best things we can, then we get the best outcome. So from a researcher's perspective, what I really am aiming to provide is a workstation replacement for them. So I don't want them to own anything but a really cheap laptop, and they connect to me to do everything. So I store all of their data, provide all their tools, give them the fanciest toys I can afford at the time. And the primary way that the people interact with my system is through desktops, which hurts really serious HPC people inside, because I think I'm running, by the end of next month, I'll be running 140 odd desktops or something like that. So they're provisioned all of the time. So people come along. I've probably got about 60 at the moment, and normally by about lunchtime, they're all fully used. So, which is another problem in itself. This particular project is being run all around the country. So primarily I'm located, does that show my mouse show up? Yes, it does. I'm down here, and this is where the largest community is, primarily because most of the characterisation equipment is actually in Victoria, not for any other reason. All right, so just to give some context about how many desktops I've run since we started, so we're up over 33,000. I think the last time I checked I was nearly up to 35,000. And the users is more than that now. It's about 800 different users, unique users who run all the variety of desktops that we have. One of the things to realise when you run these interactive environments, I only have two types of users. Ones who log in and do the job that they came to do and then log out. I love those people because I give them a $50,000 node for as long as they want to do their thing, and if they get on and they use it for 2 hours and then they get off, then someone else can use it. The unfortunate thing is there's lots of people who do the complete opposite end of that spectrum, and they put in whatever my max wall time is on the cluster, and then they have their desktop for the entire wall time. I've got to remind myself that that's a success, because now they don't use a workstation, they're constantly on my cluster. But try explaining that when you're justifying the, whatever it is, 0.5% average CPU usage for that particular desktop for however long it's been going, months at a time. Not going to talk about that. So where do I deploy containers? So we have a very eclectic group of people in our system. So I have software from nearly every discipline, I think now, including HAS, the humanities, arts, social sciences. So all of those wonderful pieces of software are incredibly tricky to get going on a HPC system, because I think pretty much every one that I support is written by someone who's never been on a HPC system before. So that's a significant challenge. So for the point of why we want the federated software stacks is that because a lot of these, I did stop, the word pieces of junk keeps coming into my head. These wonderful pieces of software is that they're very tricky to install. So if one person figures it out, it's better off that that one person then makes some instructions so other people can do it. So for us, we have about 5 or 6 really large domains. So we have single particle processing, there's cryo-electron microscopy, neuroimaging, bioinformatics. Use that term loosely, that's very broad. I'm just trying to think of others. Atom probe, atomic force microscopes, so that they each have their own software stacks, which have their own complexity inside them. So what we've started doing is at each of those sites, they have domain experts. And what we do is we go around and make sure we go and talk to them about, hey, how do you get this piece of software going? And then we get them to help make a container so that we can actually run their software. I think I've still got a piece of software that we've been working on for, I think it's 6 months now, actually, with a developer to try and make a container, and she can't actually make a container that works on anything but her own laptop yet. So I still haven't won this battle. It's ongoing. The other reason why we're really keen on the federated software is because I constantly have new communities. So my latest community, the latest light sheet community, I don't know if you've ever seen one of these microscopes. They're amazing. They're a volumetric laser measurement microscope, and they do 4D time signals. So with these microscopes, you can see cells dividing. If anybody's keen, I've got videos I can show later if you're interested. So what I wanted to come and talk a little bit about, because I want to get my head around whether what we're doing is best practice or not, or get advice. So we're still struggling a bit in that my HPC centre and the people that work for me, we're super keen on containers. I think I've probably got about 300 non-published containers on our system, which cover a whole variety of things. Primarily, I don't install anything on any CentOS box now that's not in the container. I've pretty much decided that's it for CentOS. They're going containers the entire time. But what we found is with other HPC centres, they're still very keen on installing it in more traditional methods. And the problem with that is, how do you have multiple clusters around the country where users have the same experience? We do some nice things with modules. Obviously, most HPC sites have different modules and they try and make them as consistent as possible. But even when in this project, we're not able to do that because different partners want to do things differently, weirdly enough. So the way that we're encouraging contributions to our software stack is through something that people know how to, well, I should clarify that. People who've built containers before know what to do, which is use GitHub. So people can submit merge requests into our public repository, so then they can pull their own containers up there. Now, I should clarify this. On my system, I only ever build the containers on boxes I trust. So my containers are always built on kit that I've built and have all the security over. It's not to say that we don't encourage users to pull down containers from our repository. So those ones are built by Singularity Hub, and they seem to work just fine. Part of the reason why we were doing that too is to test whether my locally built containers are the same as the ones that I'm getting from public repositories. And for the most part, they are. Does it show up in there? I can't see that there's too many commits yet, so I'm still working on the convincing people to make more containers. How many people here use Singularity Hub? None? Few? Couple? How do you find it? I found it very tricky to use at the beginning because of the way that it's constructed in that.
It's not like Docker Hub, right? I mean, if you compare both, it's not the same.
Yeah, it was, and it's actually really challenging for users because the way that I built my repository is I've made folders so that people can pull down by tag the software. But if you look at how the Singularity Hub's built, it's actually built so you have a single repository per piece of software. Now, if you run a HPC site like me, that's 750 pieces, 750 different repositories. You've got to somehow figure out how to integrate. And someone's got a great plan for that. I'd love to hear how you're doing that. So I was just curious. I'm actually quite keen to try out the new library services to see whether that solves some of the issues that we have with Singularity Hub.
That's why it's advised always to use the Singularity build with Docker Hub instead of Singularity build, right?
Yeah.
They work in different ways.
Yeah. So the most common thing in my repository is GPU or OpenGL applications. Now, the reason why that they're nearly all containers is because getting them to work well on our cluster is very hard. The challenge that we've got then is when I run on federated systems is all of our hardware is completely different. So my hardware is currently at the moment spanning 3 generations of GPU. And at least 3 generations of CPU. One of the clusters I'm working with is 4 generations back. So the containers are helping, but we're still really struggling to figure out how do we do this. Let's put this down. So one of the things that we do, because I've got really beginner users, maybe is that the right word, is that I don't often tell them that they're running containers. Now, I've brought this up before at meetings such as this, and people get really grumpy. You need to tell them about they're running a container. 3/4 of the people that use my system struggle to SSH in. So I'm not sure me trying to explain to them that they're running in a container and that weird prompt they see now is in a container is going to help them. So what we've done with that is for the users, when they load the software module, all of the commands that they would expect to see are available outside of the container. So that means that, we'll show a really bad one. By making all the commands available outside, then the users don't see that they're running a container. And that means that they are chaining their containers together, which I just discovered one of my very advanced users was tricked into not realizing he was using containers, and he was calling about 15 containers in a pipeline at once. We went back and fixed that. But so this piece of software called eman2 is a Python application written by computational biologists, and not just one computational biologist, a whole bundle of them. So it's got its idiosyncrasies, this one. And this is the container that helped us discover the bug in Singularity that you could only have a certain character file for your definition, otherwise it broke. This one broke it. So this container, obviously complex to build, got to bring in a heap of software, compile a whole bundle of stuff, set a whole variety of environment variables, which people invariably break because it's Python and they love setting Python path everywhere. So once you've got this container built, for us, then the way that we hide it is by creating a script like this. What this script does, very cleverly, is just pass whatever command you want in. So we use this for any of the containers where even whether there's 1, 2, or in this case, I think there's 500 and, has it got how many there? 557 symlinks for this one. This is as bad as it gets, pretty much. But you can do it. I mean, this is a really nice way of making this because it helps the users use the latest version of the software, which is quite hard to get on. The other thing that we found that's really important to get right is to make sure that we're bind mounting everything correctly. So every container on our system bind mounts in the local folders. So if you needed to know that you're running in a container, then you need to know the bind mount commands. So that's what we found. For everybody else, they never need to see them. Enough of that. Probably the only disadvantage we found to running like this is increased support burden for us occasionally. If you're running really new pieces of software, they persist in changing the binary names, which makes for all sorts of weirdness for people. All right. Does anybody recognize the temporal segment networks repository? You'd be like shaking if you recognize this one. Of all of the machine learning things that we've installed, this one wins hands down as the worst. Let's see if I got the fantastic thing is that they do provide decent instructions for building the container. And it's got lots of the machine learning frameworks in it, and you need CUDA, and so it's non-trivial to build this one. But it builds and it tests fine. And then when you run it, it throws an inordinate number of errors that are very confusing to figure out. Now for this particular one, they gave you some helper scripts. Those helper scripts have a number of assumptions that basically break every HPC system on the planet, in that they assume that you've got write access everywhere, pretty much. It's super duper unhelpful. So this one is this one's bad in that the community that's coming along and using this can't use the command line. But they need to be able to know how to use Git because they need to be able to pull down a second copy of the scripts so that they can edit their own and run their thing. This is one where hiding the fact that they're running in a container actually works super well, except for the point where they need to figure out how to use Git themselves. I'm just trying to check here. So the way this one works so nicely is that when you pull down the repository and run the helper scripts, whenever you call in those commands, it just fires up a container to run each of those commands. So I've never actually wanted to plot I/O for this, and I never will, because I don't want to know. But this thing works very efficiently in that because of the containers themselves being a single file, it actually loads in and the container starts up even faster. One of the comments back from the user was, wow, this starts way faster than anything I've seen. Oh, that's right, that's good. Please don't contact the help desk again. But this, yeah, so running the container like that and not telling them they're inside the container actually worked really well. I'm just trying to think if there's any others. So I'd be really happy to hear people's opinions about whether they tell users what they're doing or not, or whether you're really lucky to have very clever people in your system and you're all clever people. That would be fantastic. I think for us, the real challenge is how do we get people to contribute? How do we get them to help? I mean, and that's the point of this federated activity is how do I actually get domain experts to come in and partner with me? Because I never want to be one of those HPC centres that's the ministry of no. Like you come along with your temporal segment networks and like I got them to actually request at another HPC site, and that HPC site said it's too hard, we can't install it, which was good for me because it made me look better, but it made me feel bad because I go, well, how do I share the fact that we've learned how to run this piece of software? And that wasn't super helpful. So the last thing I probably want to cover is the way that we're encouraging users. So anytime that we partner with people and we hear back to them after they've used the container and they say, I want to make this change, that's the decision point for us to help them, right? Because at that point they're motivated to do something themselves. So anybody who's running annoying Python modules that are tricky to install and they want to run their own ones, this is the thing that gets them over the line. This is how I encourage them, because I say, well, here's how you get all your dependencies really conveniently. Here's how you write the script, and now you can run this anywhere. And so that's how we're helping them. So we actually show that their software can run in other places. I sincerely wish that I wasn't the one building the first container every time. I know everybody here who builds them regularly. Building the first one is always awful because you're the one who finds out every way that it can go wrong. So if you can find someone else to contribute that's really super duper helpful. Oh, one thing I was going to bring up, and I keep meaning to ask the question, is how many people are having great success with MPI with their containers? I mean, you don't hear back from people that their container just works. I'm really curious around this. We're a Mellanox technology partner, and that doesn't help me because I can't run MPI singularity containers that go multi-node yet. And it's primarily because the way that the MXM libraries and stuff work, they're not portable. I actually took down at another site, not my own, I took down 3 nodes that we were running these MPI containers from because the MXM libraries in them crashed the nodes, completely locked them. I had to ring somebody and tell them that I'd broken their cluster, which is really good when another cluster admin calls you to tell you you've broken the cluster. So we're still trying to figure out how to do that. So, I mean, if anybody's got anything published online, I'd really love to hear about it.
It's weird to break the cluster because, I mean, if you have different versions of MPI, it will not just work, but to break the cluster.
Yeah,
I've definitely run into this exact problem where for some versions of the user space components, like they mismatch very poorly with the kernel space, and I've had machines lock up.
yeah, I mean, it's interesting because we've got this layer where you've got kernel space things and user space things, and depending on what hardware is coming through is how good, bad, or indifferent that is. Like there was I can't remember which version of the Mellanox driver, it was horrible. Like I'm not a networking expert by any stretch of the imagination, but it had a bug inside it that when you ran it inside the container, it would blow out the kernel memory, right, and the machine. It was completely bizarre. Anyway. Probably the last thing that I wanted to talk about is the way that we're building containers. So I wear two hats at my work. I wear one where I only look after peak users, and my boss actively tells me to say, unless they're a peak user, go away. And then on the other half of my brain, I'm the egalitarian part in that I provide the Characterisation Virtual Laboratory to everybody in the country. I don't care who you are, right? If you work at a university, I'll give you an account. So trying to balance those two ends of the spectrum is interesting. So for our container work, I need to be able to run containers on really cheap commodity systems that someone's got sitting under their desk to the really expensive ones that I'm running now, where I'm running DGX1Vs as my compute machines. So I want to run those containers there as well as on my basic system. So the only way that we've been able to do this so far is to actually make separate containers that are tagged. Has anybody had any success with making a container that can detect the hardware effectively? Yeah, I've fiddled with some of the NVIDIA containers that can detect the stuff, and I've still crashed a few of them. I'm still... No? I was hoping to have that one answered. That's not helpful. I'm going to avoid that. All right, that's probably enough for me. I do want to thank everybody who's worked with me on this, and especially my funders, the ARDC. They've been very kindly funding us every year to continue these activities. And the other named people up there are people who have been working with on making the particular containers for a whole variety of evil things that their sites want. Very happy to answer any questions or talk through any really annoying pieces of software that you have. And if you've got a definition, I'd love to put it in my repository.
For your MPI use with containers, did you install MPI inside the container, or you're just using mounting? Because you could do this either way. So are you mounting MPI inside, or you are installing the similar version of MPI inside the container?
To answer that, I've been using Singularity since it came out, pretty much. So I've tried every different way of doing MPI and a variety of different versions. The majority of what I'm doing now is trying to match the version inside the container as outside, which I'm not entirely enamored with that as a solution, but I mean, that's probably what I'm stuck with at the moment. The reason why I'm stuck with that is the cluster that I do most of my work on is so sensitive to the Mellanox OFED and drivers that I can't do anything else but that. Otherwise, I either crash a node or the job crashes in ways, very strange ways that I still haven't got a straight answer out of the Mellanox driver developers yet about what's going on.
And for those drivers, do you install them or you mount them?
We've done both, and it hasn't helped anyway. What usually happens is if you mount... What we've found is if I mount them into the container from outside, I often get the MXM libraries go berserk. For whatever reason, they're not matched, or there's some patched version, or...
Okay, you have maybe some different file system, operating system for the container base.
So, there's an awful lot of CentOS users in here. I sincerely, I don't build anything with a CentOS container unless I absolutely have to. I think there's only 3 pieces of software that we have installed out of the 700 or something packages that are actually CentOS containers. The rest of them are all Ubuntu.
Okay.
Which catches me out with my Lustre file system as well, because it's painful.
Yeah, because from our experience, the safest way, but if you, it will take more, it's a bit more complex. The more safe way is to install, always install. Then you sort of guarantee that it will work. Don't mount. Make the container, treat the container as a container. but then you have to make sure about the installing the correct drivers and matching of MPI. Mounting would work, but there are some risks because it might not, it may work and may not work.
Yeah, I haven't had a strong enough use case yet for me to justify the effort of sorting out the last part of MPI. I know other people, the cryo-electron microscopy one that I'm thinking of, that's a 7 or 8 gig container because it needs a desktop inside it and needs a whole variety of MPI libraries and OpenMP and I think the TIFF libraries and all these sorts of things. So that's the only one where we actually got it going. And that was done because that was a peak facility that asked for it. The other ones that we've tried, they haven't worked. Open foam, that's awful. That's properly awful. I still can't get that to go.